later after our session will over today. Okay. So take your time and submit it. If you have missed at least one session, still it's okay. You can submit it. Okay. Okay. You see, only one page or two page I have over here. See, this distribution name is two types of name, Gaussian and this is called standard normal distribution. Okay, the characteristics of distribution. Okay, for a set of data, most of the value of the observation are clustered around the mean value, and only relatively few values will deviate on the extreme on other side on either side. Okay, normal is the sense that most of the value are clustered around the central value. Hence, it is known as normal distribution. Are you getting this definition? Why it is called normal distribution? Normal in the sense most of the value are centered around the means central value. Central value is called mean, median, and mode. So around the mean, all most of the value are centered. Okay, so that's why it is also known as normal distribution. So now come, just see, this is called bell shape curve. This shape is bell shape like this. Okay, and this is bilaterally. That means it is symmetry on the both sides. The mean value will means partition the whole means data points into two part. Okay, and point of coincidence. Okay, all these three mean equal to median equal to mode. In this type of curve, all the three coincide each other, and area under the curve is 1 or 100%. So this area is the probability of distribution. Okay, now come to this example over here. This one is very important. It is part of discussion in hypothesis testing. Okay, so before that you should know that what is the relationship between standard deviation and mean in normal distribution curve. Okay, if mean is coming in the middle, mean, median, and mode, both three are in the middle, then this thing you have to remember that this one is one standard deviation. Standard deviation is sigma, and one standard deviation means if you will go ahead of one standard deviation of mean. If mean is suppose 0, okay, and you will go one standard deviation, that will be the suppose standard deviation is 0.07. Okay, so then this is 0.07, this is minus one standard deviation. So the amount of data available in this distribution is, if the data are forming the normal distribution, then the mean plus one standard deviation is 68.3% values will be available around this first standard deviation from the mean. This is the mean value. Okay, mean value will arise somewhere over here. Okay, and this is the first standard deviation towards left, and this is first standard deviation towards right. Okay, so it says that for normal distribution, okay, for normal or standard deviation, normal distribution, okay, so mean plus or minus one standard deviation, around 68.3% data will be available over here. That's why I just told you sometime before that it is called normal distribution, because around most of the data, for a set of data, most of the values or observations are clustered around the mean value. I will show you in the Python programming, but for today's class I will just show you the theory thing. Maybe tomorrow I will tomorrow, day after tomorrow I will show you. Day after tomorrow I will be on different work. I will not take class. Okay, I have NEET exam. Okay, I will be joining as a uh, Okay, that is a different thing, but Sunday I will not take class. Okay, but for the timing, I can say that today I'll discuss the theory part over here. The theory part is that over here in the standard, if you consider one standard deviation ahead towards the mean, ahead of mean, or means one standard minus one standard deviation from the mean, then it is covering around 68.3% data over here. So that's why we are saying that normal distribution, most of the data or most of the observations are available in this region. Okay, so the next one is two standard deviation. Around 95.4% data are available in plus minus two standard deviation. Okay, so how the data, how the mean and standard deviation are related for showing your data, how it is scattered, how it is means if there are some outliers, many more outliers, then it will not form the like this normal distribution, because data are scattered over here, not in the central position. Okay, so if the data are based upon the data you are getting that it is forming a normal distribution, then you can conclude that around means near the mean value. Okay, and one standard mean plus one standard deviation or mean minus one standard deviation, 68.3% data will be available or observations will be available over here around this position. Okay, around this area you will get 68.3% data or observations. Okay, around next is in 95%, 95.4% data will be available near to this two standard deviation. Okay, this one will be 95.4% data. You just have to remember this amount of data, how much data are available for normal distribution, how much data are available around the mean, and it is only two standard deviation within the region of two standard deviation from the mean. Okay, from the mean minus two standard deviation, and this is plus two standard deviation. So this is 95.4, and around in three standard deviation from the mean, around 99.7% values are distributed, and the remaining are maybe somewhere over here, but this curve is not touching the line over here. Okay, this curve is not touching the line, it will go towards infinity. Okay, so there are some we don't know where it will reach, so that's why it is a normal distribution. So my point is that you have to remember these amounts, that mean plus minus one standard deviation around this region you will get 68.3% data, and mean plus minus two standard deviation 95.4% data, mean plus minus three standard deviation 99.7% data will be available over here. Okay, in the normal distribution, and this is a convex curve, and the point where the convex is forming concave. Okay, so that is called point of inflection. Okay, so just a simple example over here. Suppose a class of 50 students have mean hemoglobin is 129 uh, per dl millions or what, I don't know, maybe micron per dl, I don't know, and standard deviation is 3 gram per dl, then 95% of the student will be between what range? So this is the question. Then it will be calculated from this formula that already mean plus 2 standard deviation equal to 95% data. So because it is given 95% data. Okay, because it is given 95% of student will lie on which range. So now you have to write mean plus 2 standard deviation is 95% equal to 95%. So the 2 standard deviation is given over here, how much it is not given. Okay, um, so the mean value is how much? 12, right? And standard deviation is 3. So 2 into standard deviation is how much? 2 into 3, that is 6. So you have to put this one. So in the range 6 and 6, 12 plus 6 is 18. 12 minus 6 is 6. So between 6 and 18, the 95% data will be available. A class of 50 students have mean hemoglobin that is 12 gram per something, and standard deviation this one. You have to calculate in which range the students will uh, having 95 means number of observations, 95 percentage of data will be available. Okay, so this one, wait. Okay, so now this way you have to understand, maybe this type of question will come in the exam, you have to solve. So now come to normal distribution. I have one slide prepared for you. Okay, see this one. The normal probability distribution, a continuous random variable x is said to be normally distributed. So which one will be called normal distribution? If it has the probability density function represented by the equation, this one. Okay, and here mu is equal to mean of the normal distribution, and standard deviation, this is the standard deviation of normal distribution. Pi is this much. Okay, mean and standard deviation are known as the two parameters for normal distribution. Once the value of mu and mu is the mean and standard deviation are known, the shape or equation of the normal distribution is completely determined. With the value of mean and standard deviation, the shape is determined because of this formula already discussed. We'll come across it again. Properties of normal distribution is, some of the important properties of normal distribution may be listed as under. The curve is symmetrical above the vertical axis through the mean. If we fold the curve across the vertical axis, the two halves of the curve will coincide. Okay. As a result of symmetry, the mean and mean, median, and mode of the distributions are identical. That's why mean equal to mode equal to median. Okay, so mode, this is the most occurring value, that is mode. Okay, median is the partitioning the whole data point into two different parts, and mean will help us to find, means using mean you are finding how the data is scattered. Okay, so since there is one maximum point in the curve, okay, again mean is also we can say average. Okay, but here this is a distribution, that's why we have to calculate using formula. Since there is one maximum point in the curve, the normal curve is unimodal. Okay, because unimodal means there is only one mode available in the distribution. Multimodal means multiple modes will be there. Suppose this is a means curve, so there are multiple mode, one over here, one over here, and one over here. But for unimodal, it will be like only one mode, because only one mode is over here, not more than one mode is here, because this is a simple curve. Okay, so this is a unimodal. Since there is one maximum point in the curve, the normal curve is unimodal. Mu and standard deviation respectively denote the mean and standard deviation of distribution, and are also known as the two parameter of normal distribution. Okay, the curve asymptotic to the x-axis, that is, it becomes closer and closer to the x-axis, but never actually touches it. Okay, as I told you, the curve itself, uh, the curve doesn't touch the x-axis, so it is going means on the above of the x-axis. No, here it is touching. Okay, so the normal distribution, the mean deviation above the mean is 4 by 5 standard deviation. Okay, deviation about mean is 4 by 5 standard deviation. For normal distribution, the quartile deviation is 2 by 3 standard deviation. The height of the curve declines symmetrically in either direction from the maximum point. Okay, it is declining from the top. Okay, therefore the ordinates coordinates of value, not coordinates, ordinates of value x equal to mu plus minus k where k is the real number are equal. For example, height of the curve is calculated like this. For normal distribution, the coefficient of skewness beta 1 and beta 0, beta 1 and beta 2 is 0 and 3. Okay, skewness means how it is, the means the curve is looking like. So this is a curve, okay, but it is inclining towards right, so it is left skew. And if it is written like this, sorry, if it is like this, so this is right skew, okay, because it is inclining left and the values are towards right. So this is the term skewness. The total area under the normal curve and above the horizontal axis is 1, which is essentially for a probability distribution curve. Area property. This is one of the most important property of normal curve, as the shape of the normal curve is completely determined by its parameter mu and sigma. Okay, so the area of the curve is determined using this mu. Mu means mean and standard deviation. The area under the curve bounded by two ordinates also depends on these parameters. Already I discussed this one. X equal to, suppose, mu minus 1 standard deviation, mu plus 1 standard deviation. So it is covering around 68.27 data. Again, the area between two standard deviation around the mean, towards left and right, it is 95% data. 95.45% data already I have discussed, and this fractional value I have not mentioned. This one you have to remember, 95.45. Similarly, this three standard deviation around the mean is 99.73. The area beyond the normal curve x equal to mean plus minus 3 standard deviation is also 1 minus this much. So this one 0.0027, which is very small. Thus particularly we can say the whole area under the curve lies within the whole area, whole data points. Most of the data points are available around 3 standard deviation of the mean, which is also known as 3 standard deviation control limit. Okay, so that's why it is called, also the normal distribution is also called as 3 standard deviation control limit. Okay, it is possible to transform any normal random variable x with mean mu and variance sigma square to a new normal random variable z with mean 0. So the mean for the normal distribution is 0, okay, and the variance is 1. The normal distribution random variable z with mean 0 and variance 1 is called standard normal variable. Okay, the transformation is possible using this formula z equal to x minus mu by standard deviation. Okay, so here are some problems available. You have to go through and solve it. Okay, so point is that today we'll stop over here, and if you have any doubt, you can raise later. But point is that we'll solve some problems using Python programming in upcoming class. Okay, is this audible? Or? So those who have not given attendance, still you have time. You can give the attendance. For today's class, I am closing the session now. Okay, and today also I will share one attendance sheet in the same Google classroom interface. Over there you can go through and submit the attendance for previous classes as well as today's class if you have missed. Okay, and I will submit it before 24th. It is compulsory to submit by that day. So before that you have to change or modify if you need. Okay, thank you for attending today's session. Okay, and okay, let me stop this recording as well as the session, and ask your friends to join on the particular day. Most of the friends of your friends are not attending classes, so you have to inform them to attend on the particular day. The three sessions I had mentioned, external people, some experts are three experts are going to address with this Python programming as well as machine learning. So be attentive and ask your friends to join, those who are registered with this course. Okay. Okay. Thank you.